Okay, this is 7SP5, 7th grade Statistics and Probability, Standard 5, Video 1, Understanding Probability. In this standard, we are going to be working with probability of events and knowing that all probabilities are fractions between 0 and 1. And the closer to 0 or the closer to 1 an event is, that will indicate its probability or the likelihood of that event occurring. A few terms to know. I'd like you to copy these down in your journal and define them. All right, here are a couple of those terms that I've defined. You could pause the video and write that in. And here is the equation that we use to find the probability of something occurring. We call it the event. Please copy this down. We're going to be using that in the next few examples. And this is a chart that I'm going to need you to be very familiar with. If not, I don't do a lot of memorizing, but if there was something to memorize, I'd like you to know the fraction, decimal, percentage, and wording, all of those options for probability. All right, our first example. It says find the probability of randomly choosing a blue marble from the marbles that are shown. So looking at the right side here, we have a couple different colors of marbles, and setting up the actual question, it says find the probability. The event is a blue marble, so we're going to randomly choose a blue marble from the total amount of marbles. And if we had this in fraction form, what is the total amount of outcomes that could occur? So all of the outcomes are all of the different marbles, regardless of their color. So we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 total marbles. So that goes in your denominator. And then the numerator is the number of favorable outcomes for the event. So basically, what do we want to have happen? What are we looking for it to occur? Well, we're looking for the blue marbles, and there are 3 of them. Now, using that fraction, we are going to make sure it's in simplified form, and then determine on the probability chart what the likelihood of this event for it to occur. So let's look at that probability chart. We said that the probability of 3 out of 10, which is 3/10, will fall somewhere on this table. Is it closer to impossible, which is a 0% chance, or is it closer to certain, which is a 100% chance? The problem that we have right now is that all of our fractions are not in tenths. So what we can do is we can create new fractions, replacing the fractions that are currently on our table by using the denominator of 10. And I think the easiest place to start with that would be right in the middle. And we are going to alter this 1/2 using a denominator of 10. So they're actually all going to be using a denominator of 10 now. All right, so we're going to make some equivalent fractions here. And the equivalent fraction to a half, well, if I have 10 items in the denominator, a half would be 5 of them. And if you think about that fraction being reduced, 5 over 10 reduces to 1/2. All right, so we'll eliminate that 1/2 now because we have the equivalent fraction. And I think maybe going over on the edges would be the next easiest thing for us to do. So if I have a 0 and my denominator is 10, my numerator would have to be 0 because 0 divided by anything is equal to 0. So we have 0/10 representing 0. We have 5/10 representing 1/2. And let's go all the way down to the other edge, and we see that we have 1 whole. Well, if I'm going to take a denominator of 10, what would go in the numerator to make it 1 whole? I'm going to eat a whole pizza, so if there are 10 slices, I'm going to eat all 10 of them. So 10 out of 10 now represents the 1. All right, what are we going to do about these fourths? The fractions called a fourth and 3/4. All right, well, if I have, if it's halfway between 0 and 5, and I don't know the representation for a fourth in the denominator of tenths, then I can take the halfway point or the mean average of 0 and 5. Well, the halfway point between, if you think of a number line, and I'm at 0 and 5, what's the halfway point between those two? And that would be 2.5. So we have 2.5 tenths. What are we going to have for the 3/4? Same idea. What's the halfway point on a number line if I have a 5 on one end and 10 on the other? What's halfway here? Okay, so that's 7.5. All right, so I think now we have a better idea of where this 3/10 is going to fall. Let's think about it. Well, if this is 0 and this is 5 and we have 2.5 here, I would say, let's see, if this is 1, 5, this is 3, this is 2. So it's going to be right around here, I'd say. So we can kind of like draw the little arrow. So 3/10 is going to be somewhere between 1/4 and 1/2. So what's the likelihood of this event occurring? If I were to put my hand into a bag of marbles and pull out one of these 3 blue marbles, what is the likelihood? I think it's between unlikely to occur and equally likely to occur, probably closer to unlikely. All right, now, what is that as a decimal? Well, you take the top and divide it by the bottom, so the numerator divided by the denominator, you're going to end up with 3/10. You probably knew that just by saying it. And then we're going to also turn this into a percentage. And we have learned that turning a decimal into a percent, you multiply by 100, or you can move the decimal twice to the right. So we're going to move that decimal twice to the right and end up at 30%. So that is a 30% chance for the event to occur. It is, I'd say it's unlikely to occur. It could happen though, but unlikely. All right, the next example says, suppose you spin the spinner, which is divided into equal parts. What is the probability that the pointer lands on a prime number? So there are a few things we need to know here. First of all, we need to know what's the probability that it lands on a specific number, how many times can that occur, and do we even know what a prime number is? So let's go through some of those thoughts right here. All right, setting up the question, it says, what is the probability of the spinner landing on a prime number? What is that equal to? Well, we know it's a fraction. And we have to determine what a prime number is. Well, a prime number is a number that has factors of 1 and itself. So only 1 and itself are all of the factors of that number. So let's start from the bottom and think about what 9 has in terms of factors. Well, we have 1 multiplied by 9. That would make it prime. However, there's another factor that you could use to multiply to get 9, and that would be a 3 times a 3. So this one has 3 factors, which automatically does not make it prime. We call this composite. All right, the 8 has 1 and 8. 1 times 8 is 8, and we also have some other factors called 2 and 4. So that is not prime. We would call that composite. All right, think of 7. 1 and 7. Those are the only numbers that multiply together to get 7, so we would call that a prime number. And I'm just going to roll through the rest of these real quick. 6 is 1, 2, 3, and 6, composite. 5 is 1, 5, prime. 4 is 1, 2, and 4, composite. 3 is 1 and 3, that's a prime number. 2 is 1 and 2, so that's prime. And then these numbers up here at the top, 0 and 1, have a special rule. These are neither. So these are neither prime or composite. So we leave those separate. All right, now that I know what a prime number is, I need to count up the number of outcomes that could occur when I spin it. Well, they're all showing up only one time each. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. There aren't any repeats, so we have how many different equal pieces of pie? 1, 2, 3, 4, 5 on the top, 6, 7, 8, 9, 10. So we have another fraction broken into tenths. And how many of them could occur? Well, the prime numbers, we have 1, 2, 3, 4 out of 10. And we are going to need to reduce that fraction to what? 2/5. What is 2/5 equal to as a decimal? Well, 4/10 is read as 4/10, so 0.4. If you didn't know that, you can take the numerator 4 and divide it by the denominator. And then the percentage, move the decimal twice to the right. We've done a lot of that this year, and we should end up at a 40% chance. And if we were to go to the probability chart, our job then is, again, to whatever the denominator is, it happens to be a 10 again. I wish I didn't do that, but we have another 10. You can change these fractions into tenths and determine where it's going to fall. So what did we say? It was a 40% chance this time. All right, so is 40 going to be closer to unlikely or equally likely? And that is going to be determined on where you place that fraction on your probability chart. Okay, in your journal, I'd like you to define the given terms on page 2 of the flip chart, write a few sentences on what you learned from this video, and if you have any questions, write those questions down, bring them to class, and we can answer them together.